Hello everyone and welcome to NPTEL classes. Here is Chemistry Detective to solve your Chemistry class 11th NCERT problem 2.14 and 2.15 from your unit 2nd, that is structure of atom, for your NEET and JEE preparations. Let me make you understand both the problems. In problem 2.14, it is mentioned that electron in hydrogen atom is present in its fifth orbit. Electron is present in fifth orbit of hydrogen atom. Now we need to calculate how much energy is required in order to ionize this hydrogen atom, in which its electron is present in fifth orbit. Second problem is we have an excited hydrogen atom, and in this excited hydrogen atom electron is present in sixth orbit. Now we need to calculate how much emission lines will appear in its spectrum when this electron makes its journey back from n is equal to 6 to n is equal to 1. That is when electron returns back from excited state n is equal to 6 to ground state n is equal to 1. For problem 2.14, idea is that energy of electron in any orbit of hydrogen atom, energy of electron in nth orbit of hydrogen atom is equal to minus 13.6 divided by n square. Energy of electron in nth orbit of hydrogen atom is minus 13.6 by n square, and this energy is in electron volts. Now we have situation that electron is present in fifth orbit, and energy of electron in n is equal to 5 will be equal to minus 13.6 divided by 5 square electron volt. Situation is this, that electron is present in fifth orbit of hydrogen atom, and in this orbit its energy is minus 13.6 divided by 5 square electron volt. Now we have to ionize this hydrogen atom. I mean, we have to take this electron out from hydrogen atom which is residing in its fifth orbit, and for ionization I will imagine that I need to take electron. For its ionization I will imagine that I need to take this electron from fifth orbit, from n is equal to 5 to infinite orbit, from n is equal to infinity. During ionization we take this approximation, or we consider that we are taking electron to some infinite place at which it is not under the influence of nucleus, and at infinity its energy, if n is equal to infinity, its energy will be minus 13.6 divided by infinity square electron volt. In fifth orbit electron has this much energy, and we want to ionize this hydrogen atom. We want to take this electron to some infinite place where it is away from influence of nucleus, and where its energy will be equal to minus 13.6 electron volt divided by alpha square. Then how much energy we have to provide to this electron, delta E? How much energy we have to provide this electron to cause ionization of hydrogen atom? That will be equal to energy difference between that will be equal to energy difference between energy of, that will be energy difference, I mean difference between energy of electron in at infinity and energy of electron in n is equal to 5. This equation I will use here in order to solve problem 2.14, that ionization energy required to take electron which is present in fifth orbit of hydrogen atom at some infinite place, and it will be equal to difference in energy of an electron at infinity and difference in and energy of electron in fifth orbit. Now I will substitute values. Ionization energy, I need to calculate ionization energy, and ionization energy will be equal to difference of this energy. Energy of electron in at infinity is minus 13.6 divided by alpha square, minus energy of electron in fifth orbit is minus 13.6 divided by 25. 1 by infinity is 0. 1 by infinity is 0. So this term, first term on RHS side will become equal to 0. I may write ionization energy of hydrogen atom in which electron is to be taken from its fifth orbit to some infinite position is equal to minus this term will become equal to 0. 1 by infinity is equal to 0, this term will become equal to 0. 0 minus plus 13.6 divided by 25. So ionization energy is equal to 13.6 divided by 25, which is square of 5, square of fifth orbit in electron volt, and it comes, ionization energy comes equal to 3, it comes equal to 0.54 electron volt. And if I am interested to express this ionization energy instead of electron volt in joules, so I need to multiply 0.54 by 1.6 into 10 to the power minus 19. It will come, energy will now come in joules, and exact value of ionization energy in joules is equal to, exact value of energy is equal to 8.7 into 10 to the power minus 20 joules. Either way you may answer, you may write your answer that ionization energy of hydrogen atom in which its electron is present in fifth orbit is 0.54 electron volt, or you may write your answer that ionization energy of hydrogen atom in which its electron is present in fifth orbit is 8.7 into 10 to the power minus 20 joules. This value is in electron volt, this value is in joules, and for conversion of electron volt into joules I multiplied by 1.6 into 10 to the power minus 19. And general, if in problem it is said that electron is present in nth orbit of hydrogen atom, calculate its ionization energy, then general formula consider a situation that it is told to you that electron is present in nth orbit, n may be 2, 3, 5, 7, any number. Now we have to calculate ionization energy of hydrogen atom in which electron is present in its nth orbit, and formula is ionization energy. Ionization energy is equal to energy of electron, ionization energy of hydrogen atom in its ground state. I may write ground state ionization energy. Ionization energy of electron in ground state. I mean when electron is present in n is equal to 1 in hydrogen atom, ionization energy at that time divided by n square, divided by n square. Electron is present in nth orbit of hydrogen atom. Now we have to calculate ionization energy of such hydrogen atom. What we have to do, we should have in mind ionization energy of hydrogen atom when electron in it is present in n is equal to 1, when hydrogen atom is in ground state, when electron in it is present in n is equal to 1, and divide that by n square. For example, if I will solve this problem using this general formula, I can save my time. I will write ionization energy is equal to ground state ionization energy for hydrogen atom if electron is present in its first orbit, and if we are interested to ionize it, ground state ionization energy is 13.6 electron volt. Now I have to divide it by 25. It will again come equal to 0.54 electron volt, and in joules it will come equal to 8.7 into 10 raised power minus 20. Now coming to problem 2.15. In problem 2.15 it is said that it is given that in hydrogen atom is present in excited state, and in this excited state electron is present in its sixth orbit, n is equal to 6. Hydrogen atom has absorbed certain amount of energy that has resulted in its excitation, and in its excited state electron is present in its sixth orbit. Now excited state of hydrogen atom is unstable. For that case excited state of any atom is unstable. This electron in n is equal to 6 will ultimately have to return to n is equal to 1 ground state. We have to calculate number of lines, emission lines in the spectrum when excited hydrogen atom returns to ground state. When electron in excited hydrogen atom jumps back, makes electron transition back from n is equal to 6 to n is equal to 1. Hydrogen atom is present in excited state, and in this excited state electron is present in n is equal to 6, sixth orbit, n is equal to 6. Now we have to calculate number of lines in its spectrum when number of lines that will appear in its emission spectrum when this excited hydrogen atom returns back to ground state. I mean when electron returns back from n is equal to 6 to n is equal to 1. But idea is that on its return electron can follow multiple paths. Electron can follow multiple routes, a number of routes during its return from n is equal to 6 to n is equal to 1. And in each route electron transition will occur. In each route electron will come from higher energy level to lower energy level. Electron transition will occur between two energy levels. Considering that energy of these energy levels is fixed, then in an electronic transition energy is also fixed. So after every transition, one photon of one particular wavelength, one particular frequency, one particular energy or one particular wavelength will be emitted. And when we will receive all these wave numbers on the spectrum, we will get a number of lines, and we have to calculate here those number of lines. How many lines will appear in its emission spectrum? I can take shortest route. I can use this idea. in order to save my time, that number of emission lines is equal to n into n minus 1 divided by 2, where n is orbit, n is orbit number of excited hydrogen atom, yeah, or I may say n is orbit number of an electron in excited state of hydrogen atom, and in this problem n is equal to 6, electron is present in 6th orbit of excited hydrogen atom. So 6 into 6 minus 1 divided by 2, it will come 30 divided by 2, and 30 divided by 2 is equal to 15. We will get 15 lines in its spectrum. We will get 15 lines in the line emission spectrum of hydrogen when electron in it returns from n is equal to 6 to n is equal to 1. And if I may